So in this video, we'll explore the concept of present value in the context of ordinary annuity. So imagine you want to make regular payments like loan repayment or retirement withdrawal. And you're wondering, how much money would I need right now in an interest earning account to make those future payments possible? So that's where present value of an ordinary annuity comes in. So when you make regular payment at the end of each period, the account is called ordinary annuity. And if your account earn interest, the value of those future payment is less in today's dollars. So to calculate how much is needed now to fund a series of future payments, we use this formula. So in this formula, A represents the present value. That means the amount of money you need right now. And then R represents the regular payment made at the end of each period. And over here, I represents the interest rate per the period. Interest rate per period. So usually to get that, we divide R by K. Here R represents the annual interest rate and K is the number of periods per year, which means the compounded periods per year. And N is the total number of payment periods. So usually to get the N, you multiply K by T. Again, T is the number of payments, that means number of periods per year, compounded periods per year, and T is the number of years. Actually, this formula helps to determine how much money is set aside today if you want to make regular withdrawals in future, like funding a retirement account, a scholarship, or even and repaying a loan. Okay, so now let's try to come up with some examples to understand this formula. Okay, so let's read this problem together. So again, this example is about present value of an annuity. Okay, suppose a retiring couple wants to establish an annuity that will provide 2,000 at the end of each month for 20 years if the annuity earns 6% compounded monthly. How much the couple puts to the account to establish this annuity? Okay, so we have to use this formula to get the present value. So let's try to get these values. So here R is the regular payment. So here R is going to be $2,000. And here you're given the value. And T is 20 because they needs to have money for 20 years. And R is annual interest, which is 0.06. And also this is compounded monthly, which means K is going to be 12. So we need I, the interest rate per period. To get this, you have to divide R by K. So this is going to be 0.06 divided by 12. So that number is going to be 0.005. And also we need N, the total number of periods. To get that, you have to multiply K by T. So K is 12 and number of years is 20. So total number of periods is equals to 240. So now I have R, I, and N. So now I can plug this value into this formula and I can find the present value of this annuity. So let me plug this value. So R is equals to 2000. 1 minus 1 plus I is going to be 0.005 negative 240 divided by 0.005. Okay, so now you can use your calculator to simplify this and you'll get 279,16154 dollars. So that means couple can receive payment of 2,000 at the end of each month for 20 years if they put this much of money in their annuity. And also, if you do the calculations, so the money actually, the total sum of money that they will receive over time is equals to $480,000, around $480,000. But they will put this amount of money to their annuity right now to get this amount of money. So in conclusion, couple needs to invest approximately this amount of money to receive $2,000 every month for 20 years. So this is how present value of annuity help us to plan for long-term financial goals like retirement. Okay, so now let's move into the next example. Next example, it's about home mortgage. So take few minutes to read this problem. This problem is about a couple who wants to buy a house and they have a $30,000 saved for a down payment and comfortable making a monthly payment of $2,200 on 25-year mortgage, and the interest rate is 6% annually, and this is compounded monthly. So what we have to find out is the maximum price of the house that they can afford. So we will be using present value of an ordinary annuity to calculate how much they can borrow. So here in this problem, R is going to be $2,200, and I, the interest rate per period, is going to be R over K. So here R is going to be 0.06 divided by K, which is going to be 12 because this is compounded monthly. You have to take K as 12. So if you divide this number, okay, this is going to be something like 0.005, and we need N. So N is K times T. So again, K is 12 and T is 25. So if you multiply these numbers together, it is around 300. So now you have your R, I, and N. So now you can plug this value into your formula. So A is equals to 2200 multiplied by 1 minus 1 plus 0.05 negative 300 divided by 0.05. Okay, I am missing a 0. Okay, so this amount will give you the present value. So if you use your calculator to simplify this value, you'll get 341,455.10. Okay, so this is without this 30,000. So to get the total price, you have to consider this 30,000 down payment. So the total price would be, is going to be, you have to add this number with $30,000. That will be sum up to 371,455.110. So in conclusion, with their budget and the down payment, the couple can afford home valued at this amount.